Okay, so you have seen that while using the integer main, we always add the return zero as a statement. So in case you are working with the other option, that is if you write void main over here, so you have to end with the getch statement. So the reason is if we are writing int, so this is treated as the return type. So if we are expecting any integer, so we have to return an integer itself. So if we return 0, so 0 marks the success for the program termination. So with int we use always return 0, and if we use void, so void is also a return type. So with void we use the getch statement. Okay, so header file is basically the files, or you can say that the dictionaries with the keywords that are used while programming. So these keywords are fixed and the meanings are fixed, and these meanings are there in the header file. The main statement where we write integer main or void main, so this is treated as a function which holds the starting point of the program. So from here the compiler starts executing the program, and its return type can be integer or void, but cannot accept any other return type except the integer, that is int, or void. And void is always used with the getch statement in the end. So cout is again a keyword, and scene is also a keyword. So both these keywords are used while we take the input from the keyboard, or while we print or display any statement onto the display screen. So these two keywords are there in the header file iostream.h. Okay, so this is very important how we actually pre-process any program, so be it a C program or a C++ program. So the process is as follows. In the starting over here, if you see, sorry, so this is a C source code, or what we called a program source code. So this program source code is whatever you code. So it's the program, and this program is given to the compiler, and before it is given to compiler, let's see how the compiler reads this program. So if you see, the program is given, and the statements that are written before the void main, that is if we write anything with a hashtag, and these hashtag statements, or what we called it a preprocessor directive. So these statements before actually giving these statements to the compiler, these statements are pre-processed and some action is performed. That means if we write include hash include iostream.h, or hash include math.h, or any other header file or any other dictionary, so these are called the preprocessor directives. And if the program does not consist of any of these preprocessor directive, then it is given directly to the compiler. Otherwise we transform it to perform some actions while using the preprocessor directive, and then we give it to the compiler. So the compiler next converts the whole program. So if you see, the compiler converts your program, whatever you have written, after pre-processing. That means if you want to include a header file, if you want to include the dictionary, so after inclusion of that dictionary, after inclusion of all the header files that you are using during the program, so these the compiler will then convert your program into the object code. So this is the object code, and this object code is given to a linker, and this linker converts your program into executable code. So the process consists of two major portions. The first one is the compiler, and the second one is the linker. So अगर हम ये बोले कि compiler आपके program को object code में convert करता है, so after converting it to object code, the linker helps you to convert that particular object file. अगर आप किसी भी program को compile करोगे, let's suppose if I'm compiling a program in Turbo C, yeah, if I'm using a shortcut, let's suppose the shortcut is Alt and C, so to compile, and then Alt and R to run. So when I compile the program, my file that is your .c file or .cpp file, your C++ file, it gets converted into, I mean, an additional file is placed in the same folder, in the bin folder with the name, your program name .obj. So that is the object code. And after the giving it to the linker, that means after pressing Control R or Alt R, whatever is a shortcut for executing the code, then the linker executes your code and convert it into .exe file. So this .exe file is ultimately your executable code. अगर आपको किसी एक application को develop करना है in C++, so what you do is you ultimately convert your program into an exe, and then you give your particular exe to the customer for execution. So you don't give the object code, आपको जो ultimately executable file होती है, अगर आपने किसी भी setup का देखा हो, if you have the calculator or any other app, so उसकी जो .exe file होती है, that is given as the ultimate result for executing the code. So pre-processing is the first stage where your program, wherever the hashtag is written in the starting, so these hashtag or these header files are read and its content are generated in the C++ file, and it can be used further wherever the code, wherever, let's suppose you have the keyword C in, you have the keyword C out. So these keywords are placed, or its meaning is placed in that particular corresponding header files. So compilation is where you convert your program into the object file. So that is .obj file. Okay, so linking or the linker helps you to create a single executable file. So I'll give you the reason. The reason is, if you are developing a complete application, if you are developing a complete software, so there may be a case that you have to develop 5 to 6 different programs, and then finally you have to link all these 5 programs, and then you find that the ultimate result is a single executable file. So this is how the things work actually. So you have to develop the things in pieces. It's not that a single developer is working on the application, the whole application. What happens is, single executable files, or what we say single programs, are being developed. Then the linker helps you to create a single executable file from multiple object codes. So this is how the linker gets into work. So first you have the preprocessor, then you have the compilation state, and then finally you have the linking state. Okay, so using namespace std is one of the important thing. So what happens here is, if I am working on a program, a simple program where I need to just print my name or just print a single alphabet, right? So that particular alphabet or that particular statement can be printed on the output screen by using the keyword cout, right? Now this cout, as a keyword, is stored, as you all know, that it's stored, its meaning is stored within the iostream header file. So but what happens in a namespace is, namespace is a specific area, or you can say, like if you have a complete book, so that particular book has different chapters. So within that different chapter, your cout keyword is placed within this namespace, that is the standard namespace. So it's std namespace. And how you can use directly without, I mean, just without directly writing cout, you can include using namespace std. You write the statement in the beginning, like after writing the header file, and then you write the std as a namespace, because std is used for standard. So std followed by this scope resolution. So this is the scope resolution operator, and then you have to write the keyword cout. So the complete statement would be something like std, then this scope resolution operator, and the cout. So this is how you can work with the cout statement. Okay, so comments are again one of the important portion where the explanation part of the program or the documentation part is important again. The reason being, if I'm working on simple software and I am developing a module A, let's suppose, for that particular software, and I leave the job, right? So if I leave the job, my task would be given to someone else. And what if that same program is given to someone else, then how does that programmer identify what all things I have included, or what all identifiers I have made in that particular program? So just to increase the readability, just to increase wherever I have written the functions, or wherever I have written the codes, so these comments first of all are not executable. So these are non-executable, but how they help is wherever you write the comments, so these comments are ignored by the C++ compiler, they are not executed, and they give the meaning by whosoever is, let's suppose, if the other person or the other developer is reading my code, so he will become aware that these particular identifiers are used for calculation of xyz, or these particular computations are done for some reason. So all these explanations or all the explanatory statements are mentioned in the C++ code with the inclusion of these comments. So you can include a single line comment, or you can work with the multi-line comments. So this is how you work with a single line comment. So you mention something with the backslash star followed by the comment statement and then backslash star. Also, if you want to work with multi-line comments, so you can start with backslash star, and then you can span multiple lines, and then you can end with star and backslash. Okay, so this is a simple statement of how you can actually print a simple word hello world. And this is we will also do the demonstration part of this. Okay, so acceptable data types. So these are some of the acceptable data types and basic data types in C++. So if I talk of the first category, first is the simple data types, and within the simple data type, it is the integer or the support of integer values. So it's character, short, int, long, and bool. We have enum, we have floating point, and within floating point or decimal points, we have float, double, and long double. And so we have the structured, or also called as derived data type. We have arrays, structure, union, and class. And if we use the address data type, so we have the pointer and the references. So we'll also explore all these data type in the coming videos. Okay, so these are the keywords that I use. So with Boolean, you have to use bool as a keyword. With character, you have to use char. With integer, you have to use int as a keyword. With floating point, you go with float. Double floating point, you go with double. Valueless or void is represented by void. And white character is represented by wchar underscore t. Okay, so these are ranges given for each particular data types. And size of operator, we'll also demonstrate this in next video. The size of operator helps you to print the size of each and every data type that is supporting in your processor. And the data type has certain storage bytes, so these storage bytes or the sizes gets printed for each of the data types. Okay, so literals are particularly used to express your values, to express your source code. So if I write, like suppose if I want to add two numbers, so in that case I have to store these two numbers, or I have to compute these two numbers, and ultimately I have to use these two variables into some computation, and then I'll get the result. So a, if I I write something like a equals to 5, so this is a literal and it is placed in my C++ code, right? So you can go with integers, you can go with decimal as acceptable value, you can go with characters, strings, or boolean values. So, integer numerals may you have major four categories. First is the decimal numbers. The second is the octal number, which is represented by zero in the starting. The third one is zero x, that is represented as a hexadecimal number. So these are all the integer numerals. Okay, so constant is uh, a variable whose value cannot be changed throughout the program. Like suppose if I am computing the formula and I'm using pi as the variable inside that formula, so I know that pi has a fixed value and I don't want to change the value of that pi. So if I am computing like suppose I'm computing pi r square as one of the computations, so in that pi r square I can change the radius, but the value of pi cannot be changed. So in those cases where the value of a variable is fixed and cannot be changed, so there I use the constant as the variable. Okay, so all the first example is the legal and the illegal literals. So 078 is illegal because in octal the acceptable value is from 0 to 7 and 8 is not acceptable. Similarly, in 032 UU is not acceptable. So it's not acceptable as the integer literal. So this is the example of various integer literals that are acceptable. So you can write U in the end, that represents the unsigned integer, L in the end that represents the long, and UL in the end that represent unsigned long. Okay, so we'll see how we can use constant. So constant is written directly with the keyword const followed by whatever data type that you are using. So if you are working with the integer, if you are working with double, so you can use that particular data type followed by the value. So you have to assign the value for that constant. Variables, if you want to assign the variables, you can go directly with the data type followed by the name of that variable. So if it's float, you can work with decimal or float with the keyword float. If you have to use, like suppose if you are working with three integers, so you can directly write integer a comma b comma c, or you can write in three different lines integer a, integer b, and integer c. Okay, so I guess initialization portion or before that is the scope of a variable. So if I say the scope of a variable is how the variable is or where the location of that variable is. So if I say that my particular variable is declared somewhere here, so this is the age variable is declared within this curly braces. So this age variable is called as the local variable, and this local variable has a fixed area where it can be used. So it cannot be used outside because it is unknown outside. And if I say every single variable that is declared outside the main, so it's declared outside the main, integer, character, string, and number of the sons. So all these four variables are declared outside main. So these four variables form a part of global variable. Okay, so this is the scope of variables. Let's see how we can actually give the values to the variables. So if I have something like include, how we can give the header files, we are using a namespace and we can give the values directly. So like suppose I'm giving a equals to 3 or a equals to 5, so you can give values directly. You can, if you are writing something like integer result and you're not giving the value, then in that case the value is undetermined until you give the value or you initialize it with the some with some computation. So till then it remains undetermined. Okay, so in the end, I would say that there are certain keywords, and these keywords are fixed in C++ language. So you cannot use these keywords anywhere throughout the program as a variable. So you can use these keywords, but you cannot declare them as a variable. You cannot declare them as the identifier. These all these keywords has a fixed meaning, and if you use, like suppose if you want to give some condition, and on the basis of condition you want to enter the loop or enter the if condition, then you can use if statement, but you cannot declare a variable with the name if. Similarly, if I have integer, so I cannot declare the name of my user defined variable something like int, since int is the data type, and these all these keywords, the complete chart of these keywords are fixed, and all these has a predetermined or predefined task or predefined meaning for all these keywords. Okay, so if I am using the identifier, so I can define any name, I can declare it with any name, but the rule says you cannot use space. Like suppose if I'm writing something like age of dog as a name of variable, it is 100% valid. But if I write something like age space then of space dog, so this is not valid. So you can use over here underscore, that is valid. You can start your variable name with an underscore. You can start with the capital letter also, that is valid, but you cannot start with a number. So you if you write number in the starting, it is not a valid identifier. So it must be unique. It cannot be any of the reserved keywords. So these are all the reserved keywords. So you cannot use the identifier or the variable name from all these reserved keywords. Thank you. So in the next slide, maybe in the next demonstration video, we'll learn how we can use the identifiers, how we can give the values, and also some demonstration on constraints. So keep watching.